Hello students, welcome to the online lecture series of St. Andrews Institute of Technology and Management, Gurugram. Myself Satender VATS, Assistant Professor in Etce Department in Saitm. So our today's topic is shift registers, which is a topic of Unit 3 in Digital Electronics. Okay. So let's start. Our today's topic is shift registers. So till now we have already studied about combinational logics and about flip-flops as well. In the last lecture we learned about the flip-flops. Okay, so flip-flops are basically used to store one bit of information. That is, it can either store 0 or it can store 1. Okay, so a flip-flop can store 1 or a 0. That is, one bit of information can be stored in a flip-flop, and we have already seen different types of flip-flops like SR flip-flop, JK flip-flop, T flip-flop and D flip-flop. So today we are going to study registers, shift registers. So shift registers are basically used to store more than one bit of information. Okay, so sometimes in sequential circuits we need to store more than one bit. So as we know that one bit is used to store, if we have a flip-flop, it can be used to store only one flip-flop. With a combination of flip-flops we can store more than one bit. So shift registers are the circuits which are a combination of flip-flop and some combinational circuit. Okay, so shift register are basically combination of some combinational circuit and a number of flip-flops which can be used to store more than one bit of information. So basically there are four types of flip-flops, as we can see over there: serial in, serial out, parallel in, parallel out, parallel in serial out, and serial in, parallel out. So these are some of the classifications based on the way of entering the data into a shift registers, and how can we extract the outputs. So this classification is based on how we can enter the data and how we can extract the data out of a shift register. Okay, so first is serial in, serial out shift register. In this type of register, data will be entered serially into the shift register, which is a combination of 4 flip-flops if we have to store 4 bits of information, and it is taken out serially as well. That is why the name is serial in, serial out. Serial in, serial out. Data is entered serially and extracted serially from the last flip-flop. So in this configuration, the flip-flops are connected to each other in such a way that output of one flip-flop, output of one is input to the other, and output is this one is input to the other. This is how the flip-flops are connected in, serial out configuration. So data can be, there can be a shift in data in two ways, that is left shift and right shift. Either we can left shift the data left to right, or we can shift it from right to left. It is basically depends on the data, which side of the data we are entering into the shift register first. Okay, like if we have a stream of data 1 0 1 0, so this bit on the right hand side is the least significant bit. and this on the right hand side or left hand side, it is the most significant bit. You all know about that. This one is the least significant and this is the most significant bit. So if we feed our data from this side, that is, if we feed data, if we have 1010 and if we feed data into the shift register from the MSB side, most significant bit, then it will be a left shift register. There will be a left shift. And if we feed the data from LSB, that is from right to left, first this bit will be entered, then second, then third, and then the last one. So if we are following that pattern using LSB first, then it will be right to left. Okay, so let's see first the serial in, serial out, serial in, serial out, left shift. Okay, so let us consider a 4-bit of register with negative edge triggering, and you all know what is negative edge triggering. Negative edge triggering is the output, that is, this is the positive edge and this is the negative. This is positive, this is negative. So data will be entered into the flip-flop only at the negative edges when the clock goes from high to low, that is at negative edges. So data will be entered only at the negative edges. That is what negative edge triggering is all about. So here we are using 4 flip-flops to enter our data, and we are designing the left shift serial in, serial out register. So let us consider the initial states of all the flip-flops are 0, that is 0 is stored in all the flip-flops, that is Q0 is 0, Q1 is 0, Q2 is 0 and Q3 is 0 as well. The output of all the flip-flops Q0, Q1, Q2 and Q3 are 0 initially, and we need to enter the data 1 1 1 into the shift register. So let's see how we can do it. In the left shift, as I have told, the MSB will be entered first. So in the left shift, the MSB, that is the leftmost bit, will be fed first to the flip-flop. So we can see in the diagram here, we will feed MSB from this one. So one will be stored on the first negative edge into this flip-flop, and others would remain 0 0 0. Now at the second edge, this input will become 1, this will remain 1 0 0, that is we are entering 1 1 1 1 from the MSB. Okay, so on the next edge it will become 1 1 1 0. Okay, and in the last negative edge it will become 1 1 1. So data is entering from MSB into the flip-flop one by one, as you can see in the table also here. First of all, Q0 will become 1, then Q0 and Q1 both will become 1, then Q0, Q1 and Q3 will become 1, and finally Q1, Q2, Q0, Q1, Q2 and Q3 all will become 1. So data is entering from the left side, that is the MSB is feeding into the register first. So this is left shift in serial in, and data is we are getting the data serially. We are feeding it in serial way and getting out of the last flip flop in the series as well. This is the timing diagram. As you can see in this is the timing diagram, this is the clock, and data will be entered at the negative edges only. So as the first negative edge comes, the data in Q0 will become high, that is 1. On the second edge it will continue to be 1. Okay, on the second edge the data in the Q1 will become 1. Similarly at third negative edge in Q3 it will become 1, and at fourth negative edge all the values in the flip flops will become 1 1 1. So this is how it is done. Okay, similarly we can see in the serial in serial out right shift. In this the MSB will be feed first to the LSB is feed first. So if we want to feed this the data 1101, so first of all this LSB will be feeded. Okay, so first 1 will come, initially all were 0, then at the second step it will become 1 0 0 0 at the first negative edge. At the second negative edge, as the second bit is 0 in the stream, it will become 0 1 0 0. Now at the next edge it will become 1 0 1 0, and at the next edge final it will become 1 1 0 1 at the final edge. So LSB is coming first into the shift register and it will come out if we will put another bit into the shift register. So data is getting into the shift register serially and getting out of it serially as well. So this is how the right shift will go on. This is the same, we can also see in this. So first of all were zeros, then the LSB comes 1, it becomes 1 0 0 0, then the next bit is 0, so it becomes 0 1 0 0, then 1 comes, then it becomes 1 0 1 0, and then last it becomes 1 1 0, and all these transitions take place only at the negative edge. Okay, only at the negative edge, 1 by 1. So this is how a shift register works. Okay, so it can come in your MDU semester exams. He will give you a bit of a stream like this 1 0 1 0 1. If I need to store 5 bits, then I will need 5 flip flops to store this pattern. So this is how shift registers work, serial in serial out. Okay, this is the timing diagram. We can see at first edge the LSB comes into the flip flop, at second edge then bit next to LSB, and similarly it goes on. Okay, now the next is serial in parallel out, that is the data is fed into the flip flops or the shift register serially and we get the output simultaneously, that is parallel out. We get the data in parallel form, but it is feeding into the shift register serially, so it is called serial in parallel out. We can get the output from all the flip flops simultaneously, that is why it is called parallel output. So number of clock pulses required to store the whole word will be equal to number of bits in the word. Okay, how many clock pulses will be required? It will be equal to the number of bits we need to store. So in this example, let's see, we need to store 110. So data will be fed serially and we want to extract it in a parallel form, that is simultaneously from all the flip flop. So this is how the diagram will look like. This is the diagram. Here we will feed the data serially. Okay, let's see the operation. Initially, let's all the flip flops has 0 stored in it. So initially we have 000 stored. So when we apply first LSB, that is the 0, first LSB is 0 to the input at the first negative edge, that is as the first edge. This is the second and this is the third edge. Okay, so at first negative edge, since we are applying 0, so it will remain 0 0 0. When at the next negative edge comes, 1 will be applied to the input of D naught, and then flip flop naught, FF naught will set and FF1 will reset, and the corresponding word stored will be 1 0 0. As the first flip flop is getting 1, the remaining 2 will continue to store 0 0. Now when we apply the last bit to input D naught, then the flip flops F naught and F1 will set and F2 will be reset, so we will get 1 1 0. So this is how it works. Okay, at the first negative edge, the input 1 is applied, so Q naught will become 1 at the second edge, Q1 will become 1 at the third edge, and Q3 will continue to be 0. So this is how serial in, parallel out shift register works. Now the next is parallel in and serially out. So we need to feed the data parallelly and want to extract it in the serial form. So for this we need to use a combinational circuit, that is a multiplexer, to feed the data. It will have two modes, it will work in two modes, that is shift mode and the load mode. In the load mode, the data will be entered into the flip flops, data will be entered, and in the shift mode it will be shifted from one flip flop to other. Okay, and we can feed the data parallelly into all the flip flops. If we need to store 4 bits, we will need 4 flip flops, and we can extract the data serially. Okay, so let's see how it will be done. We need a multiplexer, okay, so that we can use the two modes alternatively. First the data will be loaded and that inevitably then it will be shifted. So for that we need a combinational circuit, and we have used a multiplexer over here. Here the select input is, this is S, which can be 0 and 1, and two inputs are load and shift. So if the select input is low, the data will be loaded, and if it is high, the data will be shifted into the shift register. That is why we have used a multiplexer. You have all known very well the working of a multiplexer. So this is how we can implement the multiplexer using two AND gates and a OR gate, two AND gates and one OR gate. So this is the final circuit. Here we need to store 4 bits. Okay, we need to store 4 bits, so we would require 4 flip flops. and this is the combinational circuit to choose between the operations shift and load. Okay, now if the select line, that is the shift and load line, is low, that is the select input is low, then the AND gates 2, 4 and 6 become active. That is this is 2, this is 4, this is 6. These AND gates will become active and our data B0, B1, B2, B1, B2, B3 will be stored in the shift registers. If select line is low, data will be load. Okay, on the falling edge of the clock, the binary inputs B0, B1, B2, B3 will be loaded in the corresponding flip-flops. Now for the shift mode, if we want to shift the data stored in the flip-flops, the shift load line, that is the select line, will become high. Okay, and the AND gates 1, 2 and 3 will become active and the data will be shifted. Okay, so on the falling edge of the clock, the data will shift from left to right. As we have seen, every operation will take place on the negative edges, as we are using negative edge triggering in the flip-flops. So this is how the serial in parallel in serial out shift register works. And the last one is parallel in and parallel out. We need to feed the data parallelly and want to extract it parallelly as well. So this is how the circuit will look like. Here we need to store 4 bits, and so we would require 4 flip-flops as well. So B0, B1, B2, B3 is the data which is fed parallelly, and simultaneously we are getting the data at the outputs of all the flip-flops. So 4 bits, binary bits B0, B1, B2, 3 are applied to the data inputs at D0, D1, D2 and D3 of the flip-flops. As soon as the clock edge is applied, as soon as the clock, we are providing to the same clock to all the flip-flops simultaneously. Okay, same clock pulse is applied to all the flip-flops and the data is entered parallelly in all the flip-flops in the form of 4 bits B0, B1, B2 and B3. As soon as the clock is applied, we can get the output simultaneously at all the flip-flops. That means only one clock cycle is needed to load the data. This type of transmission is used in pipelines. Okay, and truth table can be seen here. Here we can see we are using D flip-flops. Okay, so we already know whatever we feed to the D flip-flop, it will, if it is D and it is the clock, so we will get the same at the output. If I feed 1, I will get 1 at the output. If I feed 0, I will get 0. So I have used D flip-flops to show all the shift registers. Okay, so what we have seen in this lecture, 4 types of shift register: serial in, serial out, serial in, parallel out, parallel in, serial out and parallel in, parallel out. So in the next lecture we will see some of the applications of shift register in the form of counters. So this is it for the lecture. Thank you very much.